All right, I'm going to start this presentation off with a bit of math. We all know that the area of a circle is pi r squared. But does anyone know why that is? If we take to prove this, what we're going to do is we're going to take the circle and then cut it up into a bunch of rings. Then we'll take these rings and basically flatten them into rectangles. The area of these rectangles are now 2 pi r times whatever thickness of the rings that we cut. So the difference or thickness of each ring, dr is the thickness of each cut. So now the area of each one of these rings is roughly 2 pi r times the thickness of the cut. So now what we're going to do with all of these, rectangles is we're going to align them on the graph of 2 pi r. So we're going to align all of these rectangles under the graph. And the thing here that we're going to use to prove that that is how the equation works is that the smaller the difference is, the more accurate it becomes. So basically we're taking all these rectangles, adding them all together, and then that will add up to the area. Now I probably lost basically all of you there because I wasn't explaining this with any kind of visuals. I was only using equations and words. So that's actually not how we're supposed to learn. Everything I just explained, I can explain so much better using this quick clip of a 3 blue 1 brown video, slicing up the circle, taking them all, flattening them out, adding them all up together, putting them on a graph under the graph of 2 pi r. And then as we can see, if we were to make the difference or make all of these rectangles smaller, it would become a lot more accurate to the actual graph, which shows us that yes, the area of a circle is pi r squared. So we are visual learners. Learning with visuals makes everything so much easier. We can add another step on top of this though. So watching videos will make us learn a lot faster. The next step to make us remember what we learned is to add experience and being able to actually play around with the concepts that we have. So to add experience to the learning process, so basically, yeah, if we learn through experience, we remember 3 times more of what we actually learn. So to add experience and playing around with what we're learning to the learning process, I think we should use virtual reality. So virtual reality has a few aspects. It has hardware, which is basically the headset that you put on your head to enter a virtual space. And then the second aspect is the software. To build the MVP for this, so the minimum viable product, just to prove that this is something that can work, I'm going to use the Unity game engine. All right, so I have like a main design principle for this MVP is that I want to minimize the amount of what the fucks per minute while I'm coding this. So basically, I need to make the code as clean as possible so that later on I can build onto this, add more complex concepts, because for this MVP, I'm only starting off with linear equations just to prove that it can work. So let's start with an empty Unity scene. Then I'm going to add a camera rig. The reason we have this camera rig for VR is that we basically need to match a bunch of virtual cameras with the actual headset to make it so that when you turn around in real life, all the cameras in the virtual space turn around with you. So we have 3 cameras in total. We have one for your left eye, which casts to your left eye in the headset, one for your right eye, casts to the right. Then we have a center view, which basically just fills in any extra space that isn't already being viewed. Next, the main building block for this project is something called the universal cube. It's basically just a small cube that exists in the virtual space that you're able to pick up and move around. This cube, the most important thing is that it has a value. The value is a number that can change. It can go into decimals, it can go into negatives, it can basically be any real number. Next part for this MVP is that there are these things called value boxes. So in the scene, we have a desk, 2 value boxes as well, because the equation for a linear line is y equals mx plus b, and we have 2 variables to play around here. We have m and we have b. So we have these universal cubes that we're able to pick up and move around. The way these boxes work is that they measure the amount of cubes that are inside of them. So if I pick up a cube, put it into the box, if there's now 1 cube in the m box, that box is now equal to 1. So the equation for m will now equal 1. So let's say I put 2 cubes into the m box, the equation would now equal y equals 2x plus b. And then same thing with the b box, I can modify the amount of what the value is using these cubes that I can pick up and move around. And the final component is this giant graph view behind this desk. You can see the two boxes here, where as you play around with these basically cubes that you can pick up, move them, and see the change in real time as the equation changes, the graph will graph itself in real time and change the way the line looks. So again, here's the code. The way this works is that basically it takes all the points that already exist, gets rid of all of them, so then we don't create an infinite amount of points. That's something that you need to keep in mind, or else Unity will crash many times. After that, you just take a value, which is -5, because our graph only goes 5 points in each direction, and then you plot all the points. So I would demo this in VR, but because I'm in Montreal right now, I don't actually have the equipment to load this onto my VR headset and then load it back to my laptop. So instead, we'll make do with what we have. And this is just a demonstration from Unity where I'm moving the cubes around into the box. And you can see in real time that as the cube enters the box, the line changes to the equation. So the main thing I'm trying to do here, or I guess the next step that I'm stuck on, is I'm trying to implement BCIs into this to make it even more intuitive. The one I'm using is called NextMind. Basically, it allows you to do things only using your visual cortex. So you can focus on something and then get an action trigger from that. But I can't link it up to my computer at all. And I've been stuck on this for like 2 weeks now. But I think this app is something that we can use basically just as an alternative to what we already have. We already have YouTube videos. We already have Khan Academy. And both of those are great. But people learn in different ways. People remember things in different ways. So if we add one more option onto the pile of things that people can use to learn, I think the more people learn in their own ways, the better this world will be. Thank you.